Hello everyone, good evening. Okay, so I hope all of you can see the screen. Okay, and is the voice clear? Okay, all right, right. So yesterday we were talking about this Lorentz force, which is actually the electromagnetic force that acts on a particle, on a charged particle, which is in a magnetic field, right? So we divided it, or we thought of it in two parts. One is the electric force and the other is the magnetic force, right? So one is due to the electric field, the other is due to the magnetic field B, right? But here you can see that the magnetic force due to a magnetic field is dependent on the charge Q. It's dependent on the magnetic field magnetic field B vector, and also on V vector, that is the velocity of the charge, right? So that's quite different from what we have been studying in physics so far. Look at this. This does not depend on the speed or the velocity of the charge, but this one does, right? So that is something fairly interesting, and this very fact gives it importance in relative motion. Or if you think about this magnetic force, if you think about the magnetic force, it depends on velocity. So if you watch it from different frames of reference, if you watch it from different frames of reference, then the velocity will be different, right? So if velocity is different, then qv vector cross b vector will also be different, right? In fact, this is what inspired Einstein to think about the theory of relativity. Okay, this is what is necessary to understand the theory of relativity. So it is that electric field and magnetic field, actually they are two different forms of the same thing. Here you can also get that idea, right? Here you can get an idea about the connection between electric and magnetic field. Let me just give you an example. So if you would think of, let's say, two protons, okay, and let's say we are watching from here, and when we watch, we observe that both of these are at rest. Okay, we observe that both of these are at rest. Then the force that acts amongst them is only going to be Q into E. That is, one proton will create an electric field. Suppose you call this the source, then that will apply force on this one, right? So if we talk about force acting on second one, then it's only going to be this. charge of second into electric field created by first, right? Okay, and there is no velocity, so of course even if there is a magnetic field it doesn't matter. But now if you would observe this not from this frame, but let's say from a vehicle, right, which is moving towards this side with a speed v, let's say. So if you observe it from such a frame, what you are going to see is that both of these protons, they are moving towards this side with a velocity v vector, right? So in such a case, suddenly the force acting on the second proton would now become q2 electric field created by first plus q2 into v vector cross b vector. But you know, this is where things get extremely interesting, right? આમે જેટલું લખ્યું છે એટલું સિમ્પલ હોય નહીં. I'm just trying to give you a basic idea. It is that if you change frame of reference, obviously force should not change. I'm sure all of you realize that, right? Force should not change. So what really happens is, whether you observe it from this frame or from this frame, the total value of F2 is same. આ બે છે ને એ ચેન્જ થઈ જાય. So this is what is, you know, very basic thing, or this is what inspired Einstein to give a theory of relativity. This is one of those things, right? Okay, so again I'll just clarify what I said again. It's that if we change the frame of reference, force should not change, right? So this F2 and this F2, of course they're equal, but then if you look at it carefully, they don't, they seem to be completely different, right? Because here you have one more term, right? But what happens is that the electric field and the magnetic field, they are actually two forms of the same, of same what, that I'm not going to tell you. Okay, that is way beyond high school physics level, right? So there are two forms of the same fundamental force, if you want to just keep it short, right? એટલે વેલોસિટી ફ્રેમની વેલોસિટી અલગ થઈ જાય ને તો E અને B ની વેલ્યુઝ બદલાઈ જાય. It's something like that. Okay, so anyways, I think this is enough discussion, right? Don't need to dive too much into what exactly happens and all that. Okay, right? And to, you know, accommodate all these changes, Lorentz gave something called Lorentz transformation. And એવી અમુક equations બનાવી હતી which are called Lorentz transformations. અને એની ઉપરથી Einstein's theory of relativity આવે, right? Some people also accuse Einstein of simply copying Lorentz transformation and claiming that he has derived it, right? પણ એવું નથી, આઇન્સ્ટાઈને બીજું ઘણું કર્યું હતું આગળ. Okay, so nevertheless, right now what's important for you is that the Lorentz force is the total electromagnetic force, right? આટલું યાદ રાખવાનું. It's the total electromagnetic force, right? So the Lorentz force is given by Q E vector plus Q V vector cross B vector. No, Avinash, changing electric field is not called magnetic field, but changing electric field has a relation with a magnetic field. Okay, that we'll study in the chapter of electromagnetic induction. No, sorry, EM waves. In EM waves, not in electromagnetic induction, in EM waves. Okay, so this is what you need to remember. Again, to sum it up, this is the magnetic force or force due to magnetic field, and this is the electric force. Acha, હવે magnetic force ઉપર જરાક ધ્યાન આપો. That is a very important part in this chapter. So you see, this magnetic force is like this. So first of all, it's a cross product. First of all, it is a cross product. So if you want to find magnitude, then you'll have to do it like this. આ બધું તો બેઝિક્સ જ છે, 11th માં માંડ શીખવાડ્યું હતું, પણ આના માટે જ શીખવાડ્યું હતું. ઓકે, where theta is angle between v vector and b vector, right? I hope you all still remember that. And then if you want to find direction of this force, if you want to find the direction of this magnetic force, then you have to use your favorite right hand thumb rule. હવે વિચારો કેમ હું આ ચેપ્ટર ના પાડતો તો કરાવવાની ઓનલાઈન. Avinash, how is a magnetic field formed? That will study in this chapter itself. Okay, don't worry, it will come after a few topics. Okay, so if you want to find direction of the magnetic force, you have to use the right hand thumb rule. Okay, બધાને યાદ જ હશે કે આવી રીતે V હોય ને આવી રીતે suppose B હોય, right? So if you do V cross B by using right hand thumb rule, the screw arm ફેરવવો પડશે, correct? So in that case the screw will go in. તો હવે એના માટે બે સિમ્બોલ છે, બહુ ઇમ્પોર્ટન્ટ સિમ્બોલ. Inside the paper એટલે cross, okay, and outside the paper એટલે આમાં screen. Here in this year's version it is screen, right? Outside the screen, okay, and that means perpendicular, okay, normal to the screen and inside, and normal to the screen outside. So એના માટે dot. These two are very 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 important notations, કારણ કે આમાં તો હું કંઈ આમ પેન રાખીને એવું નહીં કહી શકું તમારી બાજુ ને ઊંધી બાજુ કે એવું કંઈ પણ. ઓકે, સો you have to be very careful with these. Cross for inside એટલે એવું યાદ રાખવું હોય તો રાખી શકો. This is a very dirty trick. Okay, all right then. Cross in advance nahi, only cross in is enough. Okay, so now what is the unit of magnetic field ને એવું બધું જરાક જોઈ લે, બરાબર? Unit of B is Tesla, capital T, okay, for Tesla, right? This is the SI unit. એક બીજું Gauss છે, this is SI unit, and then there is one Gauss, right? This is the CGS unit or non-SI unit, right? And frankly I forgot the relation. જોઈ લો ને, ટેક્સ્ટ બુકમાં આપ્યું હશે. આપ્યું છે? I think 1 Gauss is 10 raised to minus 4 Tesla, if I'm not wrong. I think so. Can you confirm it? Is it given in the book? મળ્યું તમને કોઈને કે હું ગોતું હવે? નો મળે તો કઈ વાંધો નહીં, પછી જરૂર આવશે ત્યારે આપણે જોઈ લેશું. ચેપ્ટર કયો? ચેપ્ટર 4. ઓકે, આ ચેપ્ટરમાં તો ક્યાંય આપ્યું નથી લખતું. હા આપ્યું છે આર્યું મળી ગયું મને મળી ગયું બુકમાં આપ્યું છે. ઓકે ફાઇન. સો that's that, right? Now let's talk about a few more basic things about magnetic field and how it behaves, right? Okay, so if you remember earlier I told you that a charge, stationary or moving anything, charge creates electric field, and then this electric field applies force on other charges, correct? આવી રીતે હોય ને, right? Similarly, a mass creates what? Gravitational field, and that applies force on other masses. This is what we have been studying. હવે આના જેવું છે, આના જેવું કે આના જેવું સમજાવું. Moving charge, I hope you remember I told you that moving charge creates magnetic field, okay? And this magnetic field applies force on other moving charges, right? On other moving charges. Okay, Vishwa, please remind me at 4:55 I will do it, right? Okay. So a moving charge creates a magnetic field, and then that can apply force on other moving charges. So obviously, see, if you look at the magnetic force formula, it is also quite clear what we have written here, right? If charge is at rest, then V is 0. So then obviously Fm is also 0. I don't think anyone has any problem with this, right? તો કોઈ એમ પૂછે, does a magnetic field apply force on all charges? No, it can only apply force on moving charges. First of all, it can never apply force on stationary charges, right? In whichever frame you are talking about. Second, if આ યાદ છે ને, if angle between V, if angle between V vector and B vector is either 0 or 180, then also Fm will be 0. Why so? Because sine 0 is equal to sine 180 degrees. Okay, no Swarali, this formula is to be used just like we use the electric field, the force applied by electric field formula. This works even if it is non-uniform, right? Okay, similarly this also works even if or whether it is uniform or non-uniform. Okay, right? This works also for uniform or non-uniform both, right? Doesn't matter, it is a general formula, right? Okay, and the third obvious case is if V vector is perpendicular to B vector, then Fm is maximum in magnitude, right? This clearly comes from sine 90 degree equal to 1, right? Okay, let's go to next interesting point. પહેલા simple mathematical symbols માં લખું છું, પછી સમજાવું. So this point number 4 is that the magnetic force is always perpendicular to the velocity of the particle. Remember instantaneous velocity, j point per જે velocity હોય એને perpendicular, right? So the magnetic force is always perpendicular to the velocity of the particle, and similarly it is also perpendicular to the magnetic field, right? So this is clearly due to right hand thumb rule, right? This is clearly due to right hand thumb rule. I hope you remember that when you do cross product of two vectors, maybe like this, then the cross product result is in some direction like this. Yaad aayu આ? Do you remember this? For example, if A and B are in the plane, તો A cross B કરીશ ને હું આમ જવાનું ને A cross B કરવાનું ને, then it will be inside, so it will be cross. Is this clear? A cross B here will be cross. Clear or not? રાઈટ હેન્ડ થંબ રૂલ આમાં બહુ જ આવશે હો. જેને નથી આવડતું એ કાલે વાંચીને આવશે. હવે રાઈટ હેન્ડ થંબ રૂલ હું અહીંયા સમજાવવાનો નથી, એટલું ફિક્સ જ છે. ઓકે, અગેન ક્રોસ મીન્સ ઇનસાઇડ, એટલે તમારી સ્ક્રીનની અંદર. અને કોઈ શરમાશે નહીં, આ વખતે તો ઘરે છો એટલે રાઈટ હેન્ડ થંબ રૂલ યુઝ કરતા કરતા કોઈ એમ પૂછે આ શું કરે તું, તો કહી દેજો આવું આવે છે અમારે. ઓકે, સો રાઈટ હેન્ડ ને બદલે લેફ્ટ હેન્ડ થઈ જાય તો પછી +4 ને બદલે -1 થઈ જશે, બરાબર ને? So you should remember that this force is always perpendicular. So એવું યાદ છે, when there is a circular motion, then we divided the force into two components. યાદ હોય તો યાદ જ હશે, I'm sure. One centripetal and one tangential. યાદ આવે છે? Same thing we did about acceleration also. We did the same thing about centripetal acceleration and tangential acceleration. How yaad chhe? So then at that time I told you that AC changes direction of velocity and AT changes speed, right? So based on what we have discussed so far, I hope all of you realize that this is quite simple and clear based on 11th standard. Magnetic force can never change speed of a moving particle. કેમ આવું? Because the magnetic force is always perpendicular to velocity. આના જેવું, આમાં velocity આમ જ હોય ને. Suppose it is moving in a circle like this. યાદ આવ્યું ને? So remember this sentence also, it's useful. Okay, magnetic force can never change speed of a moving particle. It can only change direction. Yes, એવું લખવું હોય તો લખ નાખો. It can only change direction. Right? So these are some useful ideas about magnetic field, right? And magnetic force. Okay, બાકી જે યુઝ્યુઅલ હતું ને એ તો બધું એપ્લિકેબલ જ છે, જેમ કે સુપરપોઝિશન પ્રિન્સિપલ. Suppose at one place there are two magnetic fields, then the net magnetic field is given by vector addition. આવું હવે શીખવાડવાનું ન હોય, બરાબર ને? હવે તો આ ઇન્ટ્યુશનમાં જ હોવું જોઈએ. ઓકે, Now we are going to talk about what happens if there is a wire carrying current placed in a magnetic field. Okay, I'll repeat. Actually, I'll write the title so you will understand. The title is Force on Current Carrying Conductor placed in a magnetic field. See, what does this mean? Suppose you put a current carrying conductor, means like a wire. Suppose you put a wire, right, and there is a current in the wire, and this wire is now placed in a magnetic field. Then how much force will act on that? Okay. તમને અઘરું લાગતું હોય ને તો ખાલી આવું લખી શકો, ફોર્સ ઓન વાયર પ્લેસ્ડ ઇન મેગ્નેટિક ફિલ્ડ, તો એ ચાલશે. આપણે ટોપિકના નામ નથી ગોખવાના. Right. So let's begin by drawing a nice diagram. Now here diagrams are extremely important કારણ કે આમાં બધું 3D માં જાય, એટલે ડાયાગ્રામ ડ્રો કરશો નહીં તો ખબર જ નહીં પડે શું ક્યાં કઈ ડિરેક્શનમાં હતું ને પતી ગયું. ઓકે, so let's say that there is, for simplicity right now we'll talk about uniform field. Okay, આવું સરસ આ શું ડ્રો કરું છું? This is a uniform magnetic field, right? Let's say that this is a uniform magnetic field. Okay, right? What have I shown? It is a uniform magnetic field. યુનિફોર્મ નહીં હોય તો શું કરવાનું? તો તમને ખબર છે, ઇન્ટિગ્રેશન કરવાનું, બરાબર ને? એવું આપણે કેટલી વાર આવ્યું છે, but we'll talk about that at the end. So here is a uniform magnetic field that is cross, that is inside the screen, right? Normal to the screen. આમ સ્ક્રીન ની ઉપર પેન મૂકો ને પેન નો પોઈન્ટ સ્ક્રીન ઉપર આવે એવી રીતે, સમજી ગયા ને? પરપેન્ડિક્યુલર ટુ ધ સ્ક્રીન એન્ડ ગોઈંગ ઇનસાઇડ. જોજો બહુ જોરથી ન કરતા, સ્ક્રેચ પડી જશે પછી તમે મારું નામ લેશો. Okay, and let's say that in this field there is some અચ્છા આમ ડ્રો કરીએ તો પછી 90 ડિગ્રી જ આવશે દર વખતે. I'm so sorry, we'll have to change the diagram to, you know, to reflect it properly. Just give me 1 minute. Thankfully we have easier diagram. So suppose this is uniform magnetic field. Okay, and inside this magnetic field we put some wire. Acha color to dekhato nathi am. Let's say that here we have put a wire of some length L. અત્યારે straight ભલે રહ્યો, પછી આપણે બધું કરશું. Right, let's say this is a wire of length L, okay, from P to Q, right? And suppose in this wire a current is flowing, I, right? Suppose in this wire a current is flowing. Okay, so now we are going to find out how much force will act on this wire or on this conductor which has a current. Of course you may have a question, current આવ્યો ક્યાંથી? ક્યાંય લગાડ્યું તો નથી. All that I've kept hidden or secret because right now the focus is on this part of the wire. Okay, બાકી બેટરી લગાડો એટલે કરંટ આવે, એ તો તમને બધાને આવડે. So I'm sure you don't have any problem with that. So we can write it as follows now. Okay, consider a conductor PQ carrying a current I, right, placed in a uniform magnetic field B vector. Okay, see the angle between the conductor's length and magnetic field is theta. So suppose this angle is theta. Okay, suppose this angle is theta. Right? Now we have to find what's the force acting on this. Right? We're going to find out what's the force acting on this whole thing. So see, we can just say a rough word માં તમને સમજાવી દો પેલા concept શું કરવાના છે. We can just say that the force on PQ due to the magnetic field should be nothing but addition of force on individual charges. Correct? કારણ કે current flow થાય છે, so charges are moving. I'm sure you all realize that current is flowing, so charges are moving. So when there are moving charges in a magnetic field, they will have a force acting on them. So each force ultimately PQ ઉપર લાગશે. Okay, this idea is clear, everyone? Is idea okay for you? બસ આ એક જ main part. So based on this, it's actually very simple to do. We could write that so if you consider the current I, so we can talk about its drift velocity, right? So you could say the drift velocity of charges be Vd, right? Let's say the drift velocity of the charges be Vd vector, right? So now based on this, we can talk about the force acting on an individual charge, right? As velocities due to random motion average to zero. આનો શું મતલબ થાય? Of course, random motion does not contribute to flow of charge, right? So the velocity due to random motion overall for the entire conductor will give zero, right? So as velocity due to random motion average to zero, the magnetic force on PQ can be considered to be Fm is equal to addition, that is sigma, of एक charge carrier નો charge Q is this okay? But see, because all have overall the same drift velocity and overall, sorry, in a vector, overall they have the same drift velocity. બધા charge carriers ની same જ હોય, average કરો તો, બરાબર, over a time. So what this means is that instead of adding, I could just say that for 1 it is going to be Q into Vd cross B. Then for suppose n charge carriers, it is n into Q into Vd cross B, right? For n charge carriers, right? So you could say that this for n charge carriers is Fm vector equal to n times Q into Vd cross B, right? What is n? The total number of charge carriers, right? બહુ બધા free electrons ને એવું હોય ને. So for 1 it is q into vd cross b. So for n, this is simply going to be n into q into vd cross b. Now this is where we are going to use some formula from third chapter, right? Third chapter માં આવી formula આવી હતી, I is equal to n e a v d, right? Okay, so we are going to use this here, right? So first of all, you could write n is equal to small n into area into length. Okay, બાકીનું લખી લેશો ને જાતે, where a is what and l is what. Okay, એવું તો આવડશે ને લખતા. Is this fine? Okay, small n is number density. યાદ આવ્યું? કદાચ કોઈને હજી યાદ ન આવ્યું હોય તો. Small n is number density of the charge carriers. So finally, you could write it as Fm is equal to small n into q into a into vd, right? Okay, into l cross b. હમણાં એક વસ્તુ કરું છું, આવી રીતે લખ્યું. Okay, now what does this mean? You might think this was a vector, now I'm not writing it as a vector, I'm writing L as a vector. Just give me one moment to explain. See, if you talk about charge carriers, then charge carriers are going to have the drift velocity in the direction of electric field if you assume they are positive. યાદ છે ને આ VD અને E નું એક રિલેશન હતું આવું. This is force. યાદ આવ્યું આવું? So what is happening is that the charges will drift in some direction and the current will also flow in the same direction. બરાબર ને? જે ડિરેક્શનમાં ઇલેક્ટ્રિક ફિલ્ડ આવશે એ ડિરેક્શનમાં ડ્રિફ્ટ થશે અને એ ડિરેક્શનમાં કરંટ ફ્લો થાય, right? Okay, so what we are doing is, because current cannot be a vector, let me clarify this. We know current is not a vector. So what we are doing is, instead of indicating the direction by drift velocity, we are indicating the direction by L, that is length. Okay, so we are saying where L vector is a vector with direction same as current and magnitude equal to length of conductor. Tell me yes or no and then we'll proceed further. Is this sentence clear? Take your time, no hurry. This is actually a very important formula, so I don't want you to be confused about it. Take your time. Is this sentence clear? આવું એટલે જ કરીએ છીએ કે આની જગ્યાએ I લખી શકાય, but I is not a vector. ફરી વખત બહુ ફટાફટ થર્ડ ચેપ્ટરનું યાદ કરાવી દઉં છું, that suppose you create a potential difference V between the two ends, then there will be an electric field inside this in this direction. So electric field create થાય, so because of that the charges will drift. So drift velocity will be in this direction. So if charge carriers are positive, if charge carriers are positive, then Vd and current will be in the same direction. પણ ઇલેક્ટ્રોન હોય તો ચાર્જ કેરિયર્સ નેગેટિવ હોય એટલે ડ્રિફ્ટ વેલોસિટી ઊંધી બાજુ આવે ઇલેક્ટ્રિક ફિલ્ડથી. ડ્રિફ્ટ વેલોસિટી આમ આવે ઇલેક્ટ્રોન્સમાં, બરાબર ને, અને કરંટ તો આમ જ ફ્લો થાય, બરાબર. સો ultimately what I'm saying is that electric field and current are going to be in same direction, right? So if you don't put the sign of charge એટલે એને તમે પોઝિટિવ જ અઝ્યુમ કરો તો Vd અને કરંટ બે સેમ ડાયરેક્શનમાં જ છે. So I'm assuming this as a vector which has same direction as current. So basically direction ખાલી આની હતી એના બદલે આને ચોંટાડી દીધી ને ઓલાની કાઢ નાખી. I hope you see that. Okay, nothing else has changed. ખાલી direction આની ઉપરથી આના માથે પહેરાવી દીધી, right? That's all we are doing. We are just playing with the direction. That's it. So finally Fm vector is equal to, okay, so now have a look at what I'm making a box around. NQAVD, that is current. L vector cross B vector. આવું કેમ કરવું પડ્યું એ તમને હમણાં સમજાઈ જાય, કદાચ હજી એ ન ખબર પડી હોય તો આવું ન લખી શકાય. I hope you realize why. Suppose આપણે આવું ન કરીએ તો આપણે આવું કંઈક લખવું પડે. This is wrong because current is not a vector. ઓકે, એટલે આવું કંઈ લખવાનો તો સવાલ જ નથી થતો. કરંટ ઇઝ નોટ અ વેક્ટર. ઓકે, સો ઓફકોર્સ યુ માઇટ ક્વેશ્ચન, તો લેન્થ ક્યાં વેક્ટર છે? તમે મને પૂછશો, મને ખબર છે જે લોકોએ વિચાર્યું હશે એ લોકોને તરત એવું થશે કે લેન્થ તો વેક્ટર નથી. સો દેટ્સ વાય વી આર ગોઈંગ ટુ નાઉ ચેન્જ ધીસ એન્ડ એક્સપ્લેન a meaning here, right? આ જે ફોર્મમાં દેખાય છે ને એને આપણે થોડું ચેન્જ કરશું. Here લખજો આગળ, IL vector is called current element. Okay, IL vector is called current element. Okay, so what is a current element? Current element is a vector. Current element is a vector in direction of current. Okay, current element is a vector in direction of current. આ છે ને current element. Okay, right? And is obtained by product and a multiplication of length of conductor with current flowing through it. આ બહુ લાંબુ છે, બરાબર, પણ આમ થોડું તમને વ્યવસ્થિત સમજાવવા માટે લખું છું, બાકી ઘણાને તો આવડી ગયો છે. I into L જે હોય એને કરંટ એલિમેન્ટ કહેવાય, એમાં કંઈ બીજું છે નહીં. ઓકે, સો ધીસ ઇઝ વોટ વી ગેટ, રાઈટ? પણ આમાં આપણે બહુ બધા અઝમ્પશન્સ કર્યા છે, એટલે આટલું એક ડેરિવેશન છે, રાઈટ? પછી હવે આમાં બધા અલગ અલગ કેસીસમાં શું થાય દેટ વિલ ટોક અબાઉટ. ઓકે, રાઈટ? આટલું લખાઈ ગયું. તો હવે સમજાવવાનું ચાલુ કરું. What are the different possibilities and what to do in those situations? Shall we go ahead? Okay. Right. So first of all, we are going to talk about what if it's not straight. Right? સૌથી પહેલા ચાલુ ત્યાંથી કરીએ. What if the wire is not straight? Here we have taken a straight wire. I'm sure all of you can see that. Right? એટલે જ ક્યાંય વચ્ચેથી ડાયરેક્શન ચેન્જ ન કરવી પડે. રાઈટ? વોટ ઇફ ઇટ્સ નોટ સ્ટ્રેટ? ઓકે, તો હવે આ બધું છે ને બોર્ડ એક્ઝામમાં કોઈ નહીં પૂછે. પણ આ બધું સમ્સ કરવા માટે કામનું છે. ઓકે, સો ફર્સ્ટ પોઈન્ટ, if wire is not straight, okay, but let B be uniform and B is uniform, હજી એની જ વાત ચાલે છે, પછી નોન યુનિફોર્મનું પછી જોશે, બરાબર? પહેલા આટલું બધું નાખો. if wire is not straight and B is uniform, so let's take an example. suppose wire છે ને bent હોય, આવો wire છે, લે suppose the wire is like this, right? તો શું કરવાનું ખબર છે? let's say this point is R. So what we'll do is we will divide this into two. Suppose current arm flow થાય, we will divide it into two current elements, right? We will divide this into two current elements અને પછી આવું લખવું પડે. મેગ્નેટિક ફિલ્ડ છે ક્યાં છે એ મેં દેખાડ્યું નથી, right? So you'll have to do it like this. Is this fine? ઓકે, આ આપણી વર્ષો જૂની તો નહીં, સોરી, તમે હજી ગયા વર્ષે 12th માં આવ્યા, અરે 11th માં આવ્યા. The strategy is that whenever we come across a complicated object, right, we come across a complicated shape, we try to divide it into simple parts, right? So here we have divided it into two simple parts, two straight lines. Is that fine? Hey, topo pade છે કે નહીં? Can you hear me, everyone? Okay. Right. Now some maths. What's common? You can clearly see I is common. Okay. And then I'll have to write L1 vector plus L2 vector cross B vector. Right? So actually L1 vector એટલે છે ને PQ vector થાય. Sorry, PR vector થાય. અને L2 vector એટલે છે ને RQ vector થાય. B magnetic field છે, ક્યાં હતો કાલ? Okay. So what is L1 vector plus L2 vector? Do you realize it is nothing but PQ vector? Yes or no? Is this clear? L1 vector plus L2 vector will give you PQ vector by triangle law of addition. Shortcut મળી ગયો જો. The shortcut is you have to take shortcut, right? The shortcut is that you have to take shortcut. So what does this mean? So suppose it was like, let's say this was 3 meter and let's say this was 4 meter, right? So magnetic field hoy, then what you'd have to do is, instead of considering to separate this and this, we can do it very easily just by taking one vector going from here to there with suppose, okay, current eno I hoy and length any 5 meter lei levani. You understood that? Let's say this was a right angle, giving a simple example, right? So what we do is, instead of taking two pieces, just take the shortest length and it will give you the same result in every way. Clear? So now let me write the conclusion of the first point. It is that we take L vector as the shortest length. We take L vector as the shortest length, right? પણ એમાં છે ને direction છે, please be careful. You should not take it from Q to P. You must definitely take it from P to Q because current was flowing like that. Clear? Okay. चलो एकदम फटाफट आनी application. Okay, let's solve a question. Suppose that here is a circle, semicircle actually, right, of radius 3 meter, and this semicircle is placed in a uniform magnetic field which is crossed like this. Okay. right? It is everywhere. And in this wire, in this curved wire, there is a current of 2 ampere. In this curved wire, there is a current of 2 ampere. Radius of the loop is 3 meter. Okay. Now you have to find that if the magnetic field, its magnitude is 2, let's say its magnitude is 4 Tesla. Suppose the magnitude of magnetic field B is 4 Tesla. Then find magnitude of force acting on wire. Also find direction. Okay, also find direction. Chalo. Also find direction. હવે અહીંયાથી છે ને રાઈટ હેન્ડ થંબ રૂલ આવી ગયું. એ હવે ઉપર નો થાય. અમન બધાને ક્વેશ્ચન જોવાનો ને. People, I want answer of direction also. Also find direction of this force. Okay, magnitude અને direction બે જોઈએ. અવિનાશ એવું નહીં, આ ડાયાગ્રામમાં ક્યાં ઉપર નીચે લેફ્ટ સાઈડ, રાઈટ સાઈડ, અંદર બાર, ડોટ ક્રોસ, જે રીતે લખવું પડે. ઓકે ફાઇન. Come on people, come on. Hint, this is a curved wire but uniform field. This is a curved wire and uniform field. તો શું કરવાનું? શોર્ટેસ્ટ લેન્થ લેવાની. Okay Himani, very good. No Kia. Jia, it is wrong. Check it. No Devanshi. ચલો હું કરાવી દઉં. બરાબર. No Deval, your answer is not right. Okay, have a look. First of all, like I said, we have to draw the shortest length from here to here, કારણ કે કરંટ આમ જાય છે, બરાબર ને? તો આ થઈ ગઈ શોર્ટેસ્ટ લેન્થ ડ્રો, એને કહી દો એલ વેક્ટર. ચલો હવે મેગ્નિટ્યુડ, હા પહેલા મેગ્નિટ્યુડ FM ઇઝ ઇક્વલ ટુ ILB sin θ. કેમ આવું? કારણ કે ડાયરેક્ટ વેક્ટર ફોર્મમાં શું છે? IL વેક્ટર ક્રોસ B વેક્ટર. What do we take L as? Shortest length. Okay, બરાબર, એટલું ક્લિયર? I 2 ampere. Length, આ લેન્થ નું મેગ્નિટ્યુડ કેટલું છે? 6. ક્લિયર? into B magnetic field 4 Tesla into sin theta. Theta means angle between L and B. Again, theta means angle between L and B. So L right side છે અને B cross છે. તો બે વચ્ચે 90 degree થાય. This is something I can't show you now. Okay, ક્લાસરૂમમાં બહુ ઈઝી હતું ને, અહીંયા તમારી ઉપર છે હવે બધું. Is this 90 degree clear between L and B? Okay, so now what's the final answer of magnitude? 2 into 6, 12, 48. Yes, 48 Newton is the magnitude. હવે direction. Okay, direction cannot be done without right hand thumb rule. L cross B, L cross B કરવાનું છે, બરાબર ને? તો L cross B કરશો એટલે છે ને upward આવશે, આમ આવશે. Clear? Upwards in this diagram. Okay, ઓલરાઈટ દેન, જતા જતા એક ક્વેશ્ચન હોમવર્કમાં આપતો જાઓ, બરાબર, પછી પૂરું કર્યો. ટેક અ સ્ક્રીનશોટ વેન આઈ ટેલ યુ, ટેક અ સ્ક્રીનશોટ. Okay, take a screenshot now. This is a rectangle. Okay. Screenshot taken, everyone. Okay. Now you can go. Right? No problem. I won't teach anything else. ખાલી એક પહેલાનું બતાવવાનું છે ને એ દેખાડી દઉં. ઓકે, ચૈત્યા જોઈ લેશ આમ ફટાફટ. ટેક અ સ્ક્રીનશોટ. Vishwa, then I'll show what you wanted to see. ચૈત્ય ડન? હા અમન, તારું દેખાડ દે જલ્દી જલ્દી. ચલો મારે પછી 11th માં ભણવાનું. અરે ચૈત્ય શું કરે તું યાર? અમન, this is yours. Okay. Is this what you want, Vishwa? Done? Okay, all right. Goodbye, everyone.